Good day, student. Today we're looking at quantum numbers. There are 4 quantum numbers. 1 is the principal quantum number. 2, we have the azimuthal or the angular momentum or subsidiary quantum number. 3, we have the magnetic quantum number. 4, we have the spin quantum number. But before we continue, let me specially welcome you to School of Chemistry. If you're watching us on Facebook, TikTok, or YouTube, please hit the subscribe button so that you have access to our videos. Now let's look at the principal quantum number, denoted by the symbol N. This quantum number describes the energy level or the shells around a nucleus. So when you have the nucleus of an atom, we have the first shell, and that shell is denoted by the principal quantum number N, which is equals to 1. We'll call it the K shell. The second shell is denoted by the principal quantum number N equals to 2, and is called the L shell. The third shell is denoted by the principal quantum number N equals to 3, and is called the M shell. The fourth shell is denoted by the principal quantum number N equals to 4, and is called the N shell. So we'll have the first shell, the K shell, L shell, M shell, and the fourth shell, which is the N shell. Now the total number of electrons in any given shell is given by the formula 2n squared, while the total number of orbitals in each of the shells is given by the formula n squared. So given an energy level n, the total number of electrons it can accommodate is 2n squared, and the total number of orbitals is n squared. So in energy level 1, the total number of electrons it can accommodate will be what? 2 times 1 squared, and that will be 2. So the first shell takes a maximum of 2 electrons, and the number of orbitals will be 1 squared, and that is what? 1. In the second energy level, total electrons will be what? 2 times 2 squared, and that is 8. So total electron in the second shell is 8 electrons. And the total number of orbitals will be 2 squared, and that will be what? 4. In the third shell, it's going to be 2 times 3 squared, and that is going to be 18 electrons in the third shell, and the total number of orbitals will be what? 9. In the fourth shell, it's going to be 2 times 4 squared, that will be what? 32, and the total number of orbitals is going to be what? 4 squared, and that will be what? 16. So that is it about the principal quantum number and what you need to know. Now let's look at the next quantum number, the subsidiary or the azimuthal quantum number, denoted by L. The subsidiary or azimuthal quantum number shows how many energy levels are in each given shell, and it takes integral value ranging from what? 0 to n minus 1. So any principal quantum number, you subtract 1 from it and you write 0 then to that number. Now given the energy level n, if we have another subtitle, subsidiary quantum number L, taking values from 0 to n minus 1, and then we can have our sublevels. So when n is equals to 1, our subsidiary quantum number will be what? We take value from 0 to n minus 1, and 1 minus 1 is 0. So the first subsidiary quantum number is going to be what? 0. In the second energy level, you are going to have n minus 1, that is 2 minus 1. So it will stop at 1. So we're going to say 0, 1. In the third energy level, where we have 3, n minus 1 will be 3 minus 1. So we're going to have values from what? 0, 1, what? 2, because 3 minus 1 is 2. So it will stop at 2. The fourth energy level is going to be n minus 1 is going to be 4 minus 1. So you have 3. So we'll stop at 3. So it's going to be 0, 1, 2, 3. Now note. I want you to note this so that you know which sublevel is which. Note, when L, which is the subsidiary quantum number, is equals to 0, the sublevel is called S. The S sublevel. When L is equals to 1, it is called the P sublevel. When L is equals to 2, it's called the D sublevel. And when L is equals to 3 is called the F sublevel. Now, when you come to energy level 1, we have L equals to 0. That means we have only one S, that is S in the first energy level. In energy level 2, we have 0 and 1. That means we have P and S, that is 2S, 2P, telling you that in the second energy level. In the third energy level, 0, that is S, 1, P, 2, D. That means we have 3S, 3P, 3D. Third energy level. Now in the fourth, we have 0, which is S, 1, P, 2, D, 3, F. So we have 4S, 4P, 4D, and 4F. Let's look at the magnetic quantum number, denoted by what? M sub L. M subscript L. The magnetic quantum number describes the number of orbitals within a given subshell. What is an orbital? An orbital is a region around the nucleus where the probability of finding an electron is maximum. Let's look at the relationship between the subshell that we have just studied and what? The orbitals. Now, it is the M sub L takes value from -1 through 0 to +1. So if L is equals to 0, we know that that is S sub level. It will take values from what? -0 to +0. And since there is no such thing as -0 and +0, M sub L will be equals to what? 0. And that means we have only one orbital. When L is equals to 1, which is our P sub level, it will take value from -1 to +1. So M sub L will be equals to -1, 0 to +1. And each of these stands for an orbital, so that we are having 1, 2, 3. That is -1 is an orbital, 0 is an orbital, and +1 is an orbital. That means we have 3 orbitals. When L is equals to 2, which is our D sublevel, we're going to take value from -2 to +2. So M sub L will be what? -2, -1, 0, +1, +2. If you count, they have -1 is 1, then -2 is 2, 0, 3, +1, 4, and then +2, 5. So we have 5 orbitals. When L is equals to 3, that is our F sublevel. It will take value from what? -3 to +3. So M sub L now, value will be what? Takes value from -3, -2, -1, 0, +1, +2, +3. And that gives us how many sublevel? 7 orbitals. So in the F, when L is equals to 3, we have what? 7 orbitals. Now, each orbital can take a maximum of 2 electrons. So the S level will take 2 electrons. The P sublevel takes what? 6 electrons because there are 3 orbitals. The D has 5 orbitals, so it will take 10. And the F has 7 orbitals. 7 times 2 will take 14 electrons. And these are the maximum number of electrons each of these sublevels can carry, depending on the number of orbitals they have. Now, these are the shapes of the different orbitals. We have the S orbital, which is spherical in shape. We also have the P orbital, the PX, the PY, and the PZ, which has a dumbbell shape. Some say it's a lobe shape. These are the 6 orbitals of the P orbital, or P sublevel. Then we have the D orbital. These are the 5 D orbitals that can take 10 electrons. Then we'll have the F orbitals. 1, 2, 3, 4, 5, 6, 7. These are the 7 F orbitals. Remember, each orbital can take a maximum of what? 2 electrons. So depending on each number of orbitals in each level depends the electrons. Now let's look at the spin quantum number, denoted by what? S. The spin quantum number describes the motion of an electron within an orbital. Now the possible value of the spin quantum number S is either -half or +half. So when an electron shows an upward movement, it is given a value of +half. And when it shows a downwards movement, it is given a value of what? -half. Summarily, the principal quantum number, the subsidiary quantum number, the magnetic, and the spin quantum number tells us the position of an electron in a given level. So for the first energy level, we have 1s. For the second energy level, we have the s and p. So we're going to have 2s and 2p. The third energy level, we have SPD. So we're going to have 3s, 3p, and 3d. And then the fourth energy level. The fourth energy level, we have SPDF. So we're going to have 4s, 4p, 4d, and 4f. If it's the first time on this channel and you find this video helpful, please subscribe, like, share, and comment.